Need a lot of new words to talk about circles and parts of circles and the things that we can have in circles. So today's lesson is really just going to be a vocabulary lesson. A lot of terms to learn about stuff in circles. So the first thing is what a circle is. A circle is defined as being the set of points in a plane. So that's an important distinction, that a circle needs to be a flat figure, not a three-dimensional figure. So it's in a plane. It says it is the set of points that are all equidistant or the same distance from a given point in a plane. So we've got a point, we've got a distance, and we go that same distance out in any direction, and that creates a circle. The circle is just the line around the outside, or the edge. It's not the space inside. Okay? The circle is just the set of points that are all the same distance away from that given point. So it's just the line or edge around the figure. It's not the space within the figure. Okay? That point is called our center, and the distance is called the radius. A chord is a segment whose endpoints are on the circle. Okay. Lots and lots and lots of different chords I could draw. I just need to connect any two points that are actually on the circle, and that will be a chord. Questions on any of those terms? A secant is a line that contains a chord. So on the last slide, we said a chord is something that goes edge to edge on the circle. A secant is when we take it and extend that out beyond the circle. A diameter is a chord that contains the center of the circle. So a chord again goes edge to edge, and if it goes through the center also, it becomes something special called the diameter. You could draw diameters around in any direction, but they're all going to be the same length. They all have to go through that center. Chords can be all different lengths. They can be really tiny right at the edge of the circle. If I pick 2 points that are like right next to each other on the edge of the circle and connect those, it's going to be a really dinky chord. The biggest possible chord is the diameter. A tangent is a line that shares only one point with the circle. I am all out. Yep. So a tangent is a line that just brushes on the edge of the circle and shares only exactly perfectly 1 point. Okay, so it just brushes the edge of that circle and shares 1 point. So these words, tangent and secant, we use when we were talking about trig. There is a relationship to why we use those words in trig and why we're using those words as being parts of a circle. But the relationship is not a really quick one to show, and it really kind of requires a stronger understanding of trig than what you have at this point. So we're not going to go through why these things are called tangents and secants, but it is related to stuff about trig. Okay, there is a reason why these have the same names as the trig stuff that we talked about. That single point that the tangent and the circle share is called the point of tangency. And our last one for this slide, a sphere takes the idea of a circle into 3 dimensions or space. So it's the set of all points in space that are the same distance away from a point. So a basketball is a sphere. couple more terms to go, but any questions on these ones? Congruent circles should have the same radius. The plural of radius is radii. Okay. We learned way back at the beginning of the year in like chapter 1 that congruent means two things. It means the same shape and the same size. So we need them to both be circles. And for them to be the same size, the thing that's determined the size in the circle is the radius. So the radius would have to be the same. Right? So two circles have the same radius. We say they are congruent circles. Concentric circles. We've learned that when we encounter a new word, we can try to break it down to parts of it. Con can mean equal and centric means center, so they have equal or same center. So concentric circles are two circles or more. You could have lots of them, but that have the same center. Okay. Think of like tree rings or like a bullseye, that kind of idea. They all have the same center, but they're stacked inside of each other and have different radii. Our last term actually has two terms with it because there's two different ways to describe the same picture. So we're only going to draw one picture for this thing, but there's two different ways to describe it depending on which part of the picture we're focusing on. So it says a polygon inscribed in a circle or a circle circumscribed about a polygon. So a polygon we talked about a while ago is something that has multiple sides and angles. That's what polygon meant. So a triangle is the simplest kind. It has 3. Or we could have 4, quadrilateral, or 5, a pentagon. So a polygon is some kind of a figure with some number of sides. They have to be straight sides, not rounded sides. And what this says is we're going to put one inside of a circle in such a way that each vertex is on the circle. So I'm going to start with a circle, and then inside of that circle, I'm going to draw a triangle, but each point of the triangle has to be on the circle. And we could do that for a triangle, we could do it for a 4-sided figure, a 5-sided figure, a 6-sided figure. Any number of sides we can fit inside of that circle, but we do so in such a way that each corner is on the circle. So 2 ways to describe the same picture depending on which figure we put our focus. So if I'm thinking about the inside thing, the polygon, I say the polygon is inscribed because it's inside. Okay, inscribed means inside. So the polygon inscribed, or if I focus on the outside of it, the circle is circumscribed. So circumscribed means on the outside. So those both say the same thing in this picture. Polygon inscribed inside, circle is circumscribed outside. Okay? 2 ways of describing the same thing, just depending on which part of the picture you're looking at. Okay? We're going to do a few examples, just looking for some of these vocabulary words within a diagram. Okay, so the first thing that we're going to look for in this picture are some radii. Again, radii is the plural of radius. All radii in a circle are the same length. Okay, so they would all be the same measurement. And where can I find some of those radii in this picture?
OT.
OT would be a radius. We're going to use our symbols when we name these. So remember from the beginning of the year, a segment has a symbol above it to say that it ends. Okay? A radius has a specific length. It ends. It's a segment. So we need to use a symbol there to show that. Where's another radius in this picture?
OR.
OR. Another one?
OL.
OL. Are there any more?
No.
Could there be?
No.
There could be really lots and lots and lots, but we could also say OS is one because I could connect those. They're not connected in the picture, but if I did connect them, that would be another radius.
since there's a line not drawn, would you not put the line over it?
It's still a segment. A radius by definition is still a segment.
No, should we count that and we see that in our homework?
Yep, you can always think about connecting stuff that isn't connected. Yes.
What is the line above the letters?
That tells us that it's a segment, that it has a
okay.
specified length. And 2 endpoints. What about a diameter? RL. RL, and that also needs a segment symbol because the diameter has a specified length that ends at the circle. So it ends at point R and it ends at point L. It doesn't go beyond them. What about a chord? SR is one as a segment so that it ends at point S and ends at point R. RT would be one if we would draw that in. Really, we could connect any of the points on the edge of the circle as well. RL would also be one. A diameter is a special example of a chord. What about TK?
No.
Why not?
There's 2 sides.
On 2 spots. No,
It doesn't have 2 spots on the circle. So T is on the circle, but K is floating inside of the circle. It's not on the circle. A chord has to connect 2 points that are on the circle. So TK would not work as being a chord. Yep, ST would work.
There's a lot.
RT, LT, yeah, there's a lot that we could connect. Any of the points that are on the edge of the circle, we could connect in. Yeah, no, you don't have to put them all down. What about a secant?
H.
Not LH. SR, but as a line. So this is where it becomes really important that we're including these symbols because using the same letters without the symbols could mean different things. So SR that ends at the circle is a chord. SR that extends beyond the circle is a secant. Okay, a secant is a line that it contains a chord. A tangent.
So that's not the only one that works.
It's the only one that's drawn in.
Okay.
So, I mean, we could take any of those chords that I didn't write out, like ST, and put a line symbol above it, and that would be a secant if we would draw that in. Yep. Any chord that you turn into having a line instead of a segment will be a secant. What about a tangent?
That's all.
HL?
Yeah.
And a tangent, by definition, is a line. So that needs a line symbol above it. What special name would we give to point L?
A point of tangent.
A point of tangency. Okay. All right. Your assignment for tonight comes from 9.1. A hint for you, when working on problems 12 to 15, look for some special triangles, like 45, 45, 90, or 30, 60, 90. So those are not going to go away from us just when we wrap up our trig stuff. Those special triangles will continue to be important to us throughout here. So in 12 to 15, look for some special triangles.